For weeks, the scientific world has been waiting in a tense, breath-held silence, tracking, speculating, and anticipating the moment China would finally break the information lockdown. While NASA, ESA, and every major Western observatory struggled against the blinding geometry of the sun and the dust storms choking Earth's skies, one spacecraft never lost sight. One machine had the vantage point Earth could only dream of, hovering above the noise, above the atmosphere, beyond interference, orbiting Mars in perfect clarity. That machine was Tianwen-1. Tonight, its silence has ended. China has just released the first confirmed images of interstellar object 3I, Atlas, taken from Mars orbit at the very moment every telescope on Earth went blind. These frames, combined with ultraviolet scans and particle dust monitoring, reveal a side of the object no one expected to see. A side that contradicts predictions, dismantles comet models, and deepens the mystery around the most unpredictable visitor our solar system has ever encountered. These images don't simply fill the gap. They expose it. What they reveal is not merely unusual, it is impossible under every known understanding of cometary physics. The document begins where all interplanetary observation must begin: geometry. When Earth's telescopes lost visibility, Tianwen-1 happened to be in a perfectly aligned segment of its orbit, giving it an unobstructed line of sight across interplanetary space. No solar glare. No atmospheric haze. No scattering from Earth's horizon. Just a sharp, silent view from above the Martian sky. While NASA was forced to halt direct tracking, and ESA's fleet shut down all imaging attempts, Tianwen-1 simply kept watching. Its position allowed it to observe 3I, ATLAS during the most critical stretch, the days before perihelion, when comets reveal their true nature: fragmentation, jet formation, thermal stress behavior, and energy output. But what Tianwen-1 recorded was not the violent breakup Western models predicted. It wasn't chaotic shedding, disintegration, or thermal collapse. It was something entirely different: structured, bright, cohesive, accelerating. The first released frame looks subtle to the untrained eye, a faint point wrapped in a soft halo. But to astronomers, it is a revelation. The coma is massive, not thinning, not scattering, but thickening. Stabilizing. Forming a symmetrical plume around the object. Mars orbital spectroscopy confirms a dense coma, a sunward jet, and a tail clearly visible from millions of kilometers away. The real shock is the rhythm. The coma's brightness fluctuates in a periodic cycle, repeating, consistent, patterned. Interstellar objects do not produce rhythmic patterns. Yet this one did. Tianwen-1's ultraviolet sensors detected a spike in reflectivity harmonized perfectly with rotational models, except with amplitudes far too high for a small nucleus. Something was spinning faster than predicted, or reacting faster than physics allows. This wasn't passive sublimation. This was activity. As the object moved closer to the Sun, European observatories fell completely blind. Earth looked directly into sunlight, the target vanished in glare. But from Mars, Tianwen-1 maintained its clear view. The document emphasizes a chilling phrase repeated again and again: Mars was the only eye left open. During this period, Tianwen-1 captured the formation of new jet structures in real time, recorded the elongation of the dust tail, and documented the rise of the anticola, a plume stretching millions of kilometers across space. It grew far faster than any model predicted. This was not random outgassing. These jets looked directed, clean linear releases instead of chaotic spray. The authors write that a comet behaving this way should have fragmented instantly. Yet fragmentation never occurred. Photometry revealed the most troubling paradox: a brightness increase of 0.3 magnitudes with no structural breakup during a phase when disintegration is unavoidable in classical physics. The object behaved like a shattered comet without any signs of being shattered. It radiated the energy of a cracked nucleus while remaining intact. This inconsistency is the heart of the mystery. A comet cannot produce jets at this magnitude unless it exposes vast surface area, more than a single small body possesses. Unless the object is hollow, or layered, or engineered, or not a comet at all. This is the moment the document's tone shifts, from analytical to uneasy. Every instrument aboard Tianwen-1 reported the same anomaly: structure inside the coma. Not dust. Not static. Not artifacts. Real structure. A dark ridge, sharp, repeating, aligned with the jet, cuts through the envelope of light. A shape that should not exist if the nucleus were spherical or irregular. It appears intentional. Engineered. Geometric. Then comes the most damning observation. Tianwen-1 detected a sudden brightening on the far side, the cold side, opposite the Sun. Comets brighten on the sunward side as they sublimate. This object brightened away from the heat. The researchers labeled the event photometric inversion, a term so rare it has almost no use in mainstream astronomy. The implication is disturbing. The object appeared to generate or release energy internally, as though it responded to solar exposure on one side by activating something on the other. This is behavior no natural comet has ever displayed. Once the images were released, Western agencies began reconstructing the missing data gap. But there's a sense of resignation in the document, a quiet acknowledgement that Earth no longer holds the authoritative perspective. For the first time, a probe from another world was the witness while Earth stood blind. The new data challenges every existing model. The jets defy thermodynamics. The brightness evolution forces a rewrite of its orbital solution. The tail geometry contradicts its observed stability. The coherence of the nucleus conflicts with its measured acceleration. Tianwen-1's data leaves scientists with only three possibilities. The object is fragmented but somehow behaving as a unified whole. The object is hollow, layered, or internally structured. The object operates under physics we do not yet understand. The document does not commit to the final possibility, but the implications hang heavily over every line. Its concluding tone becomes almost reflective, somber even. It acknowledges that humanity is now observing an object older than the Sun using instruments younger than a century. It notes the strange irony that a mission from Mars, not Earth, provided the most significant insight into an interstellar visitor. And the final section delivers a quiet, haunting truth: we expected dust. We expected ice. We did not expect coordination. Tianwen-1 has given the world something unprecedented, an unfiltered, unobstructed view of 3I, ATLAS from beyond the Sun, from another planet entirely. The images don't answer the mystery. They intensify it. Because for the first time, we are forced to consider that the most important interstellar discovery in human history did not unfold above Earth's sky, it unfolded above Mars. In the end, the most haunting detail isn't the wrong-sided brightening, the impossible jets, or the anticola carving the void. It isn't the geometric ridge hiding within the coma or the internal luminosity acting like a mechanism. The most haunting truth is simpler: Earth never saw it. While our planet was blinded by light, a single machine orbiting another world kept watching. It captured an object that refused to behave like ice and dust. It documented a visitor that gathered energy where none should exist, maintained form when all models demanded collapse, and displayed patterns where randomness should reign. A visitor that acted less like a relic of cosmic debris, and more like a relic of something organized. Something ancient. Something built. Tianwen-1 did not just record history. It uncovered something humanity was never prepared to see.